everyone, it's Miawan, and welcome back to the paper of 2019, the 20th Cyprus Mathematics Olympiad 5th and 6th grade. This is the third and final part. We're planning to finish the rest from question number 18 to question number 25. So, without further ado, let us start. In the figure below, what is the value of the number x? Now, if you can see, x is here in this corner of what you could say looks like a piece of a pizza. So when you look, so there has to be a pattern to all of these. In this case, the pattern is adding the sum of all of them together, because here, so these are the sums. But if you look, and if you do the other side, now you will realize that the diagonal pizza pieces, you could say, they have the same equal sum. So that means that it's the same here for 4, 3, and x. Since 4 plus 3 is 7, we can say that x is free and the answer is Vita or B. But you always have to just find the main pattern to it. It may even use a formula or anything. It can be anything like that. Now, Lucia has written a list of all positive integers whose sum of digits is equal to 5. The digits of the numbers are not equal to 0. For example, one of the numbers in Lucia's list is 23. How many numbers are there in Lucia's list? So we can say 5, because 5 is just a one-digit number, doesn't have any zeros. And then basically we'll have to find two-digit numbers that are end 5. We already know the 23, but first there's 14, 23, and then you can swap them around, 32, 41. Then we have to write ones for the three-digit numbers, which means we start with the 1, and then the rest of the sum will be 4. So 1, 1, 3, 1, 2, 2, and then we can swap it around, 1, 3, 1. And again, we can't use any zeros, so that's exactly what we're doing here. Now, we have to go to 2, so that means the sum of the rest of the digits would be 3, which means we would have 2, 1, 2, 2, 2, 1. And that's all. You basically just swap it around. Now we have 3, which means the rest of the digits sum is 2, which means there's only one possible way, 3, 1, 1. And we can't go on to 4, because either way, if you do 401 or 401 or 410, either way you cannot. You're using a 0. So far, these are all the numbers. But then we can go to 4-digit numbers as well. So let's say the first digit number is 1. The rest of the sum, it has to be 4. Wait, no, sorry. The rest of the sum has to be 4 and they're 3 digits. So we can say 1112. That's easy. And then we can say 1121, then 1211, all the way to 2011, and then the 5-digit number 11101 is basically the last one. So you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You can pause the video and count it yourself and to check all of the numbers, but the answer is delta 16. Now, there's a nifty trick to this one. The following 4x4 grid is cut into 2 identical pieces. The 2 pieces have the same area and shape. One way of cutting the grid is shown below. In how many different ways can we cut the grid into 2 identical places, cutting along the lines? The shape resulting from each cut should be different from the shapes resulting from another cut. Now what we do is we get the square. So I'm going to make a 4x4 square. And the trick is to count how many like midpoints are there which are not the corners, like these. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You don't need to count the exact number, but here. So basically, these are all of the connections you can. These are all of the points you can connect to make a certain way. And now we're going to use 2 of these sets, obviously. So what you could say is that we can do this and this. There's 1, 2, 3, 4, 5, 6. It's as simple as that. There are 6 different ways. Here's some examples. There's this way itself by just cutting the square in half. And if you take a mirror image, I think if you take a mirror image, you can say if it's correct or wrong in the comments below, your opinion. You can get a mirror image of this, and the pieces are not the same as the pieces here. There's a difference. Meanwhile, if you tried to do a mirror image of this, it would be useless. Or not even a water image either, so. Question number 21. In the sum, each letter represents a 1-digit number different from 0. The sum is a number smaller than 1, as close to 1 as possible. What is that sum? Okay, so that means when you're adding, you always have to take the LCM, standing for lowest common multiple. Let me just write that. Now the LCM is basically the 2 denominators, in this case Vita and Delta. Vita and Delta, their common multiple. Like let's say we have 6 and we have 4. We list down the tables of 6 and list down the tables of 4. And you see 12 is the first pair that appears first, so we can say the LCM is 12. There are obviously better ways to do this, like let's say we have this. Wait, sorry. Oh, sorry, I was talking about factorization there, sorry. That's no pause. But anyways, yeah, so that's, you got an idea of this. Another example is the LCM of 3 and 4. That's again 12, because 3, 6, 9, 12, 4, 8, 12. The first pair you get is the LCM, basically. But if you know your multiples, it can be easy to find. And then there are prime numbers, which are only divisible by 1 and itself. Here, 83 is a prime number, which means that any prime number cannot be the product of 2 other prime numbers. So you can say 83 is wrong in this case. So, and it can't be in a multiple. In the multiples. So 83 is wrong in this case, because we can't say that, because when we're taking LCM we can't get a prime number. Now when we have 94, when we're talking about each of these variables is a digit. So the biggest digit you can get is 81 if you do 9 times 9. Now here it's 94, which is definitely bigger. Which means that we can say that is wrong. Now, since it says what is the biggest possible sum, we can say that's 71 upon 72, because that is definitely bigger and closer to 1 than 61 upon 63. So thus the answer is Vita. You can obviously say it's closer to 1 because of the denominator, where here it's 72 while in the other one it's 63. Now, basically, if you have the same numerator, but a different denominator, then the one of the bigger numerator has the smaller value. That means if we have exactly 71 upon 72, it will be closer to 1 than 61 upon 63. And anyways, that's 2 upon 6. The difference of 2 upon 63 there. Now 1 upon 63, which means Vita is again an obvious answer. B, basically. In the following diagram, letters the alpha, beta, gamma, and delta represent the total weight of the shapes that each group has. So these are all the groups. Now, any two different shapes have a different weight. If we know that alpha here is less than beta and beta is less than gamma, then which of the following is true? So we're correlating this fact with the value of delta. But before we do that, normally it helps to substitute values. Here I substituted the triangle as 2, the square as 5, and the circle as 3. Or you could use common knowledge. So basically I get the sums as 9, 11, 12, and 10. Now when it says alpha, delta is smaller than alpha, that is wrong, because delta is actually bigger than alpha, 10 is bigger than 9. Beta is bigger than delta. No, beta is smaller than delta, which is wrong. And delta is smaller than gamma, which is correct, but the beta at the start is wrong. So we can say alpha and beta is wrong. Now gamma, it's alpha is smaller than delta, smaller than beta. That's correct, because we have 9. Wait, let me just write them all down according to what they're saying. So 10 is to 9 alpha. That means that's wrong. Not 10. Yeah, it's 10 smaller than 9. That's wrong. For B, for beta, that's wrong again. Gamma, it's correct, because if we have alpha, that's 9. Delta is 10, so that follows. And then there's beta, so that follows also. Now we have delta, gamma, and then there's delta there. And that's definitely wrong. And then finally eta, it says gamma is equal to delta, and that's basically saying 12 is equal to 10, which is also wrong. So therefore gamma is the answer. But though also you can think about it with no values at all too, if you're thinking logically. But it's more helpful to just substitute values, because you can't exactly use logic to think about if delta is bigger than any of the values. It has to be via substitution most of the time, and I recommend that method, the substitution, though it might take like at least 5 minutes of your time or less. Now, Andreas's car consumes 4 liters of petrol for every 35 kilometers, and the whole car's capacity is 56 liters of petrol. So 4 liters for every 35 kilometers and then it says the whole car's capacity is 56 liters petrol. So this morning Andreas started with a full tank and drove for 350 kilometers, which therefore means if we're taking the ratio 4:35 here, you're multiplying both sides by 10, so we know that it's 40 liters. Then it says he added another 32 liters of petrol, so he used 40 liters, which means and he started with full tank, so that means 56 minus 40 is 16, plus the 32, and we would get 48 liters. And then he moved on to his destination. At the time he arrived to his destination, his tank was half full, which means we have to do 56 divided by 2. Yeah, 28. So 48 minus 28 is 20, which means he used 20 liters. But now it says how many kilometers in total did Andreas travel today? So we have the 350 kilometers, and then he used 20 liters of petrol. So basically 20 liters divided by 4 liters is 5 5, which means 35 kilometers multiplied by 5 will be the distance. What's his name? Andreas will cover. So 175 kilometers. Now we add 350 with 175, and there's your answer, 525 kilometers, and that's A. It's really simple, but I just went slow so you guys can understand it. So you can do like very quickly this method sometimes. So question number 24. The fourth column is the column in which 2 pieces of pizza appear for the first time. So this column right here. What is the next column in which 2 pieces of pizza will appear again? Since now you can notice that in the first row it's like pizza, two circles pizza, 2 circles pizza. There's a gap of 2 circles. Here it's a gap of 3 circles pizza, 3 circles pizza. So the pattern's different, but we're sure that they'll meet up. So now if we're going to the 10th one, we know there's a pizza, but there's no pizza here. Again, pizza, a circle, and then we have pizza, but we have a circle here. Then we have a circle, but there's a pizza, and here because I'm writing it down because it's not that far away according to the numbers, so I can just draw it using this and it will help. And then when you go to the 16th place, they both have pizzas, which means on the 16th column 2 pieces of pizza will be aligned together, and that's how you do it. So the answer is delta the 16th. And the last question, it says in the figure below, each letter represents one integer number from 1 up to 9. The sum in each circle is 11. If gamma is 5, then what's the value of E? So gamma is 5, which means the sum of beta and delta here will be 6. I'll just say, and also we have to put 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 is already taken. And then the sum of 6, we can just say that here it's 4, here is 2, and 11 minus 4 is 7. So we can say A is 7. So 4, 7, and 2 have been taken. Now eta plus zeta, they're equal to 9. So that's 6 and 3. So we can say 6 and then 3. Now that means there's only these 3 Greek letters left, and the values they can be is 1, 8, and 9. Now 11 minus 3 is 8, which means the sum of these two is 8. Wait. Excuse me, I have some technical difficulties here. So I just realized that sometimes if you do the pattern wrong, you get it wrong. So normally I just get it first try, but sometimes it takes some tries. So now that we know that the 2 goes here, the 4 goes here, the 9 goes here. Now the value of E and Z is 7. So we can say 6 and 1. Like always. I'm being guided by the 6 here. And anyways, now we have 10. So basically after 1, 2, 3, 4, 5, 6, 7, 8, 9, 1 is gone, 9 is gone, 5, 4, and 6 are gone, so is 2. So we only have 3, 7, and 8. And so basically that means we can say 7 goes here, 3 goes here, and 8 goes here. that all works, which means eta is 6 and gamma is the answer. Maybe sometimes for you it will take more than one try, but it works in the end. You just have to get the correct combination as shown here, and you'll be fine, and you'll have finished the paper. So let me know in the comments below how much you got in marks out of 25. For each question there's a mark of 1, and though this is not following the original marking pattern, you can just check yourself and tell me. I really love to know, and I hope you gained a lot of knowledge and improved with this paper, and we're going to be covering more papers too. So with this, I end the video, and I hope you enjoyed. Please like, subscribe, and ring that notification bell for more videos like these. I really appreciate all the support given to this series so far, and I'm going to come back next time with more. Thank you, and goodbye.